Hey, good afternoon. My name is Auligné, and we're going to talk about Jedi. And we've already had some conversations about Jedi, so hopefully everyone is interested and curious. So that one slide about the Joint Center, it's a multi-agency partnership. We have NOAA, we have NASA, Air Force, Navy as core partners, and fairly recently we also had the UK Met Office and NCAR becoming observers in that partnership. And we're really about research to operations and operations to research. We have a distributed staff with core and in-kind contributors in our annual operating plan, and we're really committed to the critical path to operations. Just one slide to remind all the stuff that was done by the Joint Center over the years in terms of trailblazing, community development, with hopefully now fairly standard working practices, but basically back then, quite innovative in terms of agile project management, and you can read the metrics. We have more than 1,000 activities on boards per week, open science with million lines of code that are open source with quarterly releases. So this is the list top right here of the releases over the past year. 24 repositories are involved in these releases, but we're also working closely with EMC and EPIC on SPAC Stack that has, to my knowledge, hundreds of packages in there as well. So it's really working nicely. A lot of automated testing. We have hundreds or thousands now of tests. And heavy use of cloud computing and containers, and including containers developed on a large number of nodes with high efficiency. A shift in paradigm for the software portability. We make it a requirement in the design rather than an afterthought. So what used to take many months to port now basically takes hours or days. And that is because basically the work is done upfront to make it portable. We're supporting right now 12 different HPCs in NOAA, NASA, DoD, academia, but there's actually a lot more that testing. And also an effort on community training. We have online tutorials, we have our forum, we have our documentation, but also had Jedi Academy's week-long training where we've trained about 35 universities and partners and international collaborators as well. Now, where's the... There we go. All right, so Jedi, this is basically, first and foremost, a consortium of jointness, trying to share as much as possible, but without actually imposing a single approach. Another way of looking at it is we want to allow as much scientific diversity as possible, but we definitely don't want to waste resources in reinventing the wheel. So it's meant to be a unified DA for the Earth system science, from bridging research and operations, and looking at scientific productivity through modular code, generic programming, separation of concerns, so adopting modern software standards. The figure on the left here is a diagram showing the different deployments that are actually actively worked on, and it might not be, there's probably more, and it might not be completely up to date, but there's actually a lot of Jedi data solution systems that are being developed in parallel for various applications, for their different partners as well. The real metric is seeing how much code is reused across these different applications, because if we keep reinventing the wheel, we haven't gained anything. But if we don't, then there's a huge multiplying factor. So if you look at the bars on the right-hand side, the first bar is actually the global GFS, FV3 GFS, and we have exactly the same interface with GEOS at NASA. The second bar is so I should say what the bars are about. There are actually a number of lines of code to assemble the executable for that application. And the colors are basically The blue ones are these open source packages that we use, mostly borrowed from ECMWF. The greens are repos that are open source that we release, and the red are the model interfaces. So all the blue and green is actually generic reuse, is the same across these different applications. The red is model specific because it's a model interface to JEDI. And so you have global atmosphere at NOAA, NASA. Then second bar is global atmosphere at NCAR with MPAS. Third one is the marine DA, so MOM6, I6 for ocean sea ice. And last one is the NOMP for the national water model. So what you see is actually the specific code that cannot be reused, that is very specific to a given model, is a really small fraction of the overall software, which is a great win. Hopefully that starts to address some of the questions earlier on. Where are we in terms of the maturity of the development, and what are the plans to actually transition this to operations? So phase one is actually, the goal is to match the existing skills of operational systems. And we're actually, we're not there yet, but we're pretty close. And so, in terms of notional timeline, I say notional because I don't control these timelines, and I don't want to commit anyone to these timelines. But basically, this is the latest information I get about the deadlines for code freezes, so that the T2O process can be put in place with various components for the atmosphere, the marine, the land, the aerosols for NASA, NOAA, Neptune, Navy, Met Office, Air Force. So it's coming up pretty quickly. And in terms of qualifying observation operators, QCs, background error covariance matrices, I'm not going to show you all the details here, but there's a lot of maturity and still a lot of work to do, but there's definitely many teams working on them in parallel and collaborating. What's also very exciting is we're not investing all of this just to reproduce what existing operational systems are doing. We're actually going to leverage a lot of new capabilities. One of them is just the idea that now you can have a system that can handle the various components of the Earth system from a unified standpoint. So this is something that we actually put in practice with Skylab. So this is just an example that you can actually look a lot more on our website through our Skylab viewers. It's at skylab.jcsda.org on our website. And these are just examples of various observations that are being assimilated. So the idea with Skylab is it's actually a quarterly release that gets a snapshot of all the latest developments that you got, and that we actually exercise in these experiments where you have the atmosphere, the aerosol, the trace gases, the land surface, the ocean, and the sea ice, all handled through that unified end-to-end system. So that end-to-end system has a data pipeline that uses YODA as a way to have a common dictionary to qualify the observations and the metadata. It puts this on a data store that we call R2D2, and has a build system that can actually configure the application to your given system, and the workflow manager that's called EWOC. And we put these diagnostics on our website that you can then use to inform on various scientific priorities. And it can be configured for various models, for various applications. By design, it's a flexible system that can run on multiple platforms and multiple applications. Here is an example with the UFS atmosphere cycled in over a month. You can find our website by using the little top left toggle here. You can swap for aerosols or marine as well. And have a look at this. All that code for actually generating these experiments is all public. You can download it today. The latest release was done last week. So where are we heading with all this? We have these three major goals that intersect, luckily. So we want to support the agencies to transition to operations. This is a very top priority. So really system hardening and course scientific quality assurance. I say coarse because there's a lot of fine-tuning that happens for each specific agency that's outside the scope of the Joint Center. This is not joint, it's specific. We also want to actually use all the agility and the flexibility of the system to rapidly integrate new innovation, and there's definitely a lot of great ideas we can bring in, and we're eager to do. And we also want to train the workforce and engage the community and use this as actually a teaching tool. So can JEDI be used for teaching? I certainly hope we manage to get that. So how do we reconcile these three pieces? I'll hopefully make Mike happy by actually saying we can actually do this through a hierarchical system development approach. So if you think about, the cost of running experiments, you can think like an operational grade experiment is very expensive. It requires a lot of CPU hours on a, expensive HPC. On the other hand, you can run with a toy model, a very low resolution model on your laptop. And of course, there's things in between. Maybe you can use the cloud. Maybe you can use your own clusters, basically. So if you think of actually using that hierarchical system, you can actually start having a hierarchy of configuration and use the flexibility of the Skylab end-to-end system to actually sort of bridge these different levels here. So we have that Skylab Large, which is basically our demonstrator that you can find on our website. That runs on HPCs. It runs in the cloud as well. Actually, the last one was running on AWS. It's basically a point of convergence for prototyping and having a continuously running prototype that's gradually getting really close to operational grade that our partners can really use for transitioning operations. So it's the idea of a concept car that you use for testing all the pieces, and that can be transitioned to a production car. Then in the middle, we actually introduced in our science workshop a couple of months ago the concept of experiment as a service. So basically, that end-to-end service that we're planning to release fairly soon if we have the right resources to dedicate to this, where basically you have all the data available, you have the build and workflow available, you have the experiment configuration manager available as well, the diagnostics, and it can run on pretty much any platform that you can think of at the moment. So that's basically for the community to being able to have actually means to be running Skylab and do very scientific relevant experiments that can directly be anchored in that large experiment that I mentioned earlier. But at the same time, let's be honest, most of us here won't have the resources to run an operational full-size, full-resolution version. So it'd be at a low resolution with basically sort of emulating the full system. And finally, the JEDI EDU is like a Skylab Small. It's a very low resolution model, or it can be also a toy model that you can actually download on your laptop, and that can be actually integrated in teaching in the university curriculum, for example, that we use for our JEDI academies for teaching DA. So we've been working so far on prototypes with Colorado State universities. They tested this for students, had really great feedback. We definitely want to expand on this with a lot more in the community. So if you're interested, please reach out. This is my final remarks. So basically, we're using the requirements of the Joint Center, this requirements of jointness. We're turning this as actually an asset by focusing on joint problems and really bringing that multiplier effect to actually get a lot of value out of this. We have a lot of commitment from various agencies listed here, and we're getting really close to operational implementation, as the notional timeline showed. And it really will unlock a lot of new transformative technologies to be transitioned a lot faster to operations. With that, I'll just let you read our vision of success for the next 5 to 10 years, and I'll take any questions you have. Thanks. Thank you.